Right, terminology. Once you're able to talk the talk, it makes it easier to learn this on your own and to study it, to read through it. IOPS, input-output operations per second. It's a measure of the rate of transfer operations. Sound simple? Is a disk SCSI flush cache command an IOP? Is a SCSI sense status command, is that a SCSI command? Is that an IOP? Would you treat that as an IOP? Would I treat everything the SCSI layer is sending to the disk an IOP? I don't. So in my definition, IOPS are input and output, therefore they are read and writes. And these are data transfer commands. And everything else is non-data transfer commands. So just to define that a little bit. This also accidentally matches what tools like IOStat show you. IOStat shows you the reads and writes. What it doesn't give you observability of is any of the other SCSI things that are sent to disks. And that can be really annoying in ZFS because ZFS sends the SCSI flush cache command. That command has high latency because it's telling the disk time to flush out the cache. And the presence of them is important, and you can't see them from IOStat. And it's because IOStat is doing IOPS. It is only doing the reads and writes, and you can't see the other command types. So when I use IOPS, I'm talking about reads and writes. If I say operations per second, I'm talking about everything, including IOPS. Throughput is the rate of work performed. In telecommunications, it means the data rate in bytes per second or bits per second. In some contexts, they'll talk about throughput to mean the operation rate, which is, it's fine. Wish we could just stick to one of them, but anyway. Response time is the time from operation to complete, like a HTTP server response time. This includes time spent waiting, called wait time, and then time spent being serviced, called service time. And we'll break them apart more in the disks chapter. Latency is the measure of time an operation spends waiting to be serviced. What's the difference between latency and response time?
Response time is total time?
Yes, and so in some contexts, this will be separated where response time is the total time, and then latency is the period of that where no progress was being made. You were waiting in a queue. And so in some contexts, especially if it's the front-end web server performance or the browser web server performance, they'll separate. Latency is just waiting before this request was initiated. However, and I redefine this in other chapters or clarify in other chapters, in some contexts, latency and response time are the same thing. And so when we talk about disk I/O latency, we're talking about the whole thing. This is also why I put this at the start of many chapters, because the terminology, because it gets used differently in different contexts, it gets really confusing. And so at the front of the chapter, this is the contexts I'm going to use these terms for now. Utilization. I'll explain that in detail. Utilization is how busy something was. Saturation is the degree that there is queued work that cannot be serviced, log length, queue length. Bottleneck is if there is a resource that's limiting the overall performance of the system, and a key part of systems performance is getting rid of them. Workload is what you apply to the system, and then caches is a fast area of storage. Straightforward. Some of them do need a little bit to think about carefully, but just want to start with them. So latency. So the first objective I had here was latency, and in this diagram I do show a common usage of latency, where response time is the entire thing, and then latency is waiting before it was serviced. And this was for a HTTP GET request. Latency is time spent waiting before an operation is performed. Latency is really confusing, and so here I called it network connection latency. Because depending on the context, this entire thing, this response time, what if this was a DNS request? If I'm using a browser, a lot of the sort of the browser web performance tools will group DNS latency as a thing, and that's that whole thing. And so DNS latency is inclusive of when it's performing a, DNS is UDP, so I guess we're not performing a connection. We're sending a request, but then we are waiting. We're response latency, and then doing the final data transfer. So this whole thing, response time, can be latency of something higher up in the stack. And that means we just want to define it. So wherever possible, DNS latency, TCP connection latency, TCP data transfer time, just to make it clear what we're talking about. Latency is a time-based metric. It's the best metric for systems performance because we can do all sorts of operations on it. We can calculate estimated speed up. I mean, we need to understand things like IOPS because IOPS is useful for characterizing the workload applied, but IOPS cannot be compared. So I cannot compare disk IOPS with network IOPS. Like, they're just different. I can compare 10 milliseconds of disk latency with 10 milliseconds of network latency. So in a way, latency is the common currency, or common unit of exchange that we'd like to convert everything to for comparison. And then abbreviations in the book, and yeah, they changed the U to be a mu in the copy edited version. So I'm using standard abbreviations.